Good morning, everyone. We ready to talk about manufacturing? All right. As mentioned, I'm the Vice President for Manufacturing and Materials for General Electric. And for those of you who aren't familiar with GE or haven't seen GE in a while, we're a digital industrial company now. We're a company focused on infrastructure for the world to make things better, whether it's better transportation, better healthcare, more reliable power. But we're also a digital company. In fact, we have over 1,000 software engineers in the San Ramon Valley. We have 100 researchers working on software technology because the world's changing. It really is a convergence of the physical and digital worlds. Now, I'm a materials engineer by training. I love working for GE because we make stuff. We make stuff that you can see, that you can feel, that you can touch, and that'll never change. And very importantly, we understand how to design it, how to manufacture it, how to service it, how to work with our customers. And that's the key in today's world. The Internet of Things is wonderful. The ability to collect more data than ever before, store more data, run analytics faster. It's amazing. But what does that mean to manufacturing? What does it mean when you can bring together those two? It means that we can understand while we're designing how we're going to manufacture. It means that while we're manufacturing, we're collecting data every day to feed back to our designers to say whether something was producible. When we're out in the field, we're able to go in situ into machines and understand how are they performing compared to the features and relate them back to the factory and back to the design. It's critical to do these days in a very fast-paced, competitive world. In fact, if we get just 1% more of productivity in a company of our size, that's worth $500 million. But it's not about money. It's about knowledge. It's about how do we be better every day? How do we take advantage of the types of technologies that you're seeing outside, that you heard about yesterday, that you'll dig deep into this afternoon, and use them in a way that we could not imagine before. Let me give you a couple of examples of how we see physical plus digital, what the power is in combining the two. Now, all of you have heard about 3D printing. You may have heard too much about 3D printing. But think about it. It's about getting the idea, translating that quickly into the ability to understand how do we build, what features can we have, layer by layer by layer. For us, it's taking time, it's getting prototypes into our hands, it's being able to put new features into our products that can increase the performance by up to 80%. But it starts with the fact that we're combining digital plus physical. If we didn't understand the properties of materials and how they will build up stresses, how they will be able to be micro-welded, which is what additive is when you get into metals, what that means to the final performance, we could not have started to design. And while we're building, we're putting more optics and more inline inspection to understand, to get more knowledge, to build even better designs. Hole drilling, something that all manufacturers do, may not sound very exciting, but what can you do when you now combine physical and digital? Well, in our world, we use a lot of electro-discharge machining, a lot of electrochemical machining. And what we're doing is we're turning the electrodes that are drilling the holes into sensors. Because of the advancements in controls technology and feedback loops, the types of holes we make, and we make over 50 million holes in our products for bolt holes, cooling holes, directing holes. These holes range in size from just a few diameters of a hair up to a foot in diameter. And they're shaped. They're not all round. They're very specific to give us the type of performance we need. So what happened when we were drilling? Well, these materials are very expensive. They can be very delicate. There can be structures that occur behind the holes. So we were very, very careful. That made us be slow, but it also made us do a lot of rework. Because we had to go back, we would check things. What is the shape? What is the diameter? Now, as we're drilling, We understand where we are, where we've been, what the shape is, where the other side of the wall is, and it helps us get better. It helps us get better first-time yield. It helps us reduce cycle time. And now this idea of using our tool as a sensor is becoming a platform for multiple types of operations. When our products are out in the field, they're in pretty harsh environments. When they come back, they don't look like the original design. In fact, when we compare it to the original digital definition, sometimes they can be off by many, many percentages. How do you repair them? How do you get them back to their original state? Well, today, many measurements are taken, many calculations are done, the engineering teams are brought in. Digital plus physical lets us be better than that. Digital plus physical lets us do things like adaptive welding, where what we're doing is we're taking scanners, and these aren't intricate CT scanners. These are scanners like used in the video game industry. And we attach them, we scan the part, we quickly compare it to the design intent in the digital definition, and then we go to the controls in our welder, we go to the robotic arm, we go to the welding electrode, and we tell it what to do. We tell it how to bring the part back to what it needs to be to go back in service. That's exponential disruption. That is changing the way we work because of technology. It may not be the kind of technology you'll see on the front cover, but it is just as important. It's just as disruptive. And it takes material scientists and design engineers and robotic engineers, industrial planners to be able to do this. Digital plus physical exponential manufacturing is about building ecosystems. No one company is going to do it. No one technology is going to do it. It's all about bringing together the fact that we have more ability to get that data through sensors, through analytics, and be able to use that data to do what we do best, which is make stuff. And it will drive us to new places. It'll drive us to be thinking about what is the next manufacturing technology we need. How do we take a manufacturing technology that's been around for 20 years and refresh it, make it look different? Because now we can do things like scan. Now we can put a new sensor. Now we can get more data. This is the future of manufacturing. A few years ago, we started to think about how we can harness this, how we can build our company differently, how we can build the ecosystem with all of our partners, all of our suppliers, all of our customers. And so for those of you who may have been following GE or see me talk, you may say, oh, there's that graphic again. But to me, it just defines what we are. We call it our brilliant factory. And it's brilliant because it's always learning. It starts with our designers, it goes to our manufacturing engineers, it goes onto our factory floors, it goes to our wonderful partners in the supply chain, back to service shops, to our customer bases. How are we always learning? How are we taking what we do, how we do it, the way it's performing, the way it turned out, the cost, the cycle time, and keep learning together? It's about bringing together these new physical technologies like additive and electrodischarge machining with sensors and data analytics and manufacturing in the cloud. It's real now. We're not all the way there. There's still a lot to do. But it starts with something we call the digital thread. Now, the digital thread, that term's been around in industry for many, many years. Some people call it the digital tapestry. Regardless, it's this idea that if we're connected, we can be better. And if we're connected all the way from design to the final product and out even into how it performs in the field, we can keep learning. And just like a thread in clothes or a thread in tapestry, when you pull on one of it, the rest of it responds. The rest of it understands what to do. The rest of it says there is something going on and we need to learn. We need to change. That's the future of manufacturing. And it'll take all these wonderful new technologies, but it'll take us working together. Because if we're all committed to a brilliant factory vision, a digital thread, we can all learn together, we can get better together, we can understand the boundary conditions of our new processes, we can understand the needs for the future. in sensors, in automation, and feedback. Here's some of the ways that we're looking at it, some of the pieces we're putting in place, and that the industry is putting in place, our partners, our peers. It's around understanding how do you manufacture right when you're thinking of a product. Doing virtual manufacturing, whether it's modeling a process like casting or welding, or whether it's taking data you get every day on a factory floor and calling it producibility data, saying, can I make a radius? Can I hold a tolerance? What about this material? Did it act differently when it came from a different supplier? And letting our designers know so that when they design a product, they can truly design for manufacturability. It's not just an event, it's not just a spreadsheet of data, it's real, it's actionable, it's right in there with their CAD tools, and it's constantly updating. It's understanding what supplier, what factory, what location, how can we do things and how can we do it right. On our factory floor, collecting that data, whether it's understanding through optics and metrology where you are in a part, so how you may have to move a cutting tool or a drill. It's about understanding as you're doing something like composite manufacturing with lots of intricacies and changes in the material. Where are you? How is it responding? Is the tool starting to wear? And how do I change? It's so dynamic to me. It's so exciting. This isn't about manufacturing a fixed process. Our processes are so important to the performance, to the reliability. But if we're learning, if we're dynamic, it's fixed, but it's able to adapt. Those sound like oxymorons, but that's the future of manufacturing. It's about being better every day. And when we go into the field, looking at new types of robotics, new types of sensors, that we can go out there and see how it's performing and understand, relating it back to design in the factory, what do we need to do? Always learning, always being enabled, thinking about the digital thread. Now, I challenged my team as we were developing all these types of technologies. I said, I want a change in a day. They said, what's a change in a day, Christine? I said, when we need to make a change, either because we find something out in a design analytic, or we get this feedback from the field, and it says, you know, if we were able to change a tolerance, we may be able to open it to more suppliers, and it really isn't mattering as much. How can I make sure that that change can proliferate through our factories, through our programming, our controllers, our suppliers, in a day? They're like, well, it takes months now, but we'll try to figure it out. That's the power of digital plus physical. That's the power of being able to say, when I make a change with a digital thread, with software enabled, with controllers, with sensors, how do I understand not only how it impacts the factory floor, but also my planning, my schedule, my logistics, tie them all together. It's so powerful because now we're all learning, now we're all connected. And I say the word connected, but I really should say collaborative. And connection is not collaboration. I can connect with any of you. We can tweet, well, I don't tweet, but you can try to tweet me. We can go on Facebook, we can send email, but how do we really collaborate? How do we really look at the problem in the same way and bring everything we have together? A vision like change in a day is something we should all work towards, because then we work together on how do we communicate, what are our protocols, what are our data architectures, how do our processes flex, what are the different capabilities. It's about understanding how it flows. Manufacturing is a system. Whether it's adaptive welding, hole drilling, 3D printing, digital thread, it's a system. Let's not talk about it as one operation or one new technology. It will never be that, because we're all impacted from how we transmit the material to how it flows through the factory floor, how we plan our schedules, look at perturbations, and we need to develop IT architectures, data protocols, new sensors, data sharing in a way like never before. We're on this journey. We've started this in a number of our factories, and it's hard, it's different, but it's what we need to do. And in fact, if we look at where we need to go, it's not about just a change in a traditional designer's and engineering drawing, but it's about being able to be in the field and take a picture with your smartphone or download some data from a sensor, being able to work with all of the logistics, all of the suppliers, all of the service engineers, and do our collaboration in the cloud. Then being able to understand where is the best place to go make a new part or do a repair. What's closest? What's most convenient for the customer? This is about having that vision together. And it's going to take all of us. It's going to take a tremendous ecosystem to do this. It's not just going to be manufacturing engineers or materials engineers or designers or IT. It's going to be all of us. And we all need to understand that we need to work together. We all need to have this vision, because then we'll truly be able to all be better, to truly collaborate, to truly show the world how exciting manufacturing is, to make stuff, to be able to have an idea and then get something physical in your hand and be proud of it. You know, we have over 400 factories across our supply chain just within GE and tens of thousands of suppliers. And when I visit those factories, the pride in the workers in what they do can never, ever, ever be replaced. And I don't want to replace it, because they have a knowledge and a feel. And how do we harness that? And how do we give them more to feel and touch and learn and give us feedback? This is the future of manufacturing. It's really about being all in. Why do I believe in this? Why am I passionate about it? Well, we did start on this journey a number of years ago with a component that we make for aircraft engine. It's a polymer matrix composite. It's a very complex material system. It makes a fan blade, which is about 3 feet in length. You can see the shape of it, twists, tolerances. It's got a metallic sleeve that goes over the front so that it's very durable in the field. It's very difficult to make. We make it in a number of factories here in the United States across GE. And we put in this concept of a brilliant factory because it was hard to do, and we had very low first-time yields, 20% or less when we introduced a new design, because we just didn't know. But we started putting sensors in. We started understanding variability of material. We started understanding different fiber strengths and how the machines that did the layup for composites responded to it. We started getting this producibility data and feeding it back to our designers. So as they changed design, improved design, made new design, they understood what we can do. We collected the data and built the physics models to do virtual manufacturing. So as we designed a new part, we could simulate it before we ever made a tool, ever ordered a material, so that we were better and faster and more iterative. And we involved everybody in this whole digital thread chain. We put in automation, but that doesn't mean robotics. Automation here meant being able to get the feedback, respond to it through our control system, and make a change, both with humans and with some automated equipment. And what are we doing now when we introduce a new design? Instead of 20% first-time yield, it's over 95%. This is real. It makes a difference. And as we look at all the new technologies that you see outside these doors, how are we going to introduce them? How are we going to make sure that we teach people? How are we going to make sure that we can use it to its fullest extent? We have to have this vision together. We have to work together to build these ecosystems. We have to be able to think about digital plus physical. So as we're thinking about it, we're working with a number of different companies and institutes, from software to physical hardware to tooling. We're working with the National Network of Manufacturing Institutes, specifically the Digital Manufacturing Institute, to be able to build new platforms where we can share data. We're using some of our software called Predix, which is a platform that you can think of putting applications on top of. And the application may be a factory flow model. The application may be the feedback from the sensor. The application may be a virtual manufacturing model. And there's lots of great software out there and lots of great partners. And we're building ways that we can communicate and try things out and collaborate without anyone worrying about their IP. Because we can code it and we can challenge and we can learn together. This is about the future of manufacturing, This is about exponential change. This is about us being together as a community to drive digital plus physical, change in a day, and exponential growth. Thank you.